Good morning, everyone, or greetings, regardless of what time it is. There's some good and some bad about today's video. I did chapter 10 last spring when we closed down in March after GCC took an extended spring break. If you were a student, perhaps you remember. And at that time, I did some videos in my kitchen. And this is my attempt to redo some of those. So I will leave those original ones up because today I am filming from my classroom, which enables me to project what it is that I sent to you on your email, on your Canvas email. I sent you the outline. So this is how we would have our normal 10.1 notes if we were in the classroom. But I have spent probably the last 15 minutes trying to negotiate my iPad in different various parts of my classroom. I've built structures that are like 6 feet tall so that you don't see this circle of glare, and I've just given up. And then at one point I was way up high, and then my head came to you from about like this. And so if you find that the other video is actually more helpful, by all means, watch both. I just want you to learn how to do the math. So, chapter 10 is all about radicals. The videos in my kitchen that I teach on my chalkboard pantry door are streamlined. So I didn't always go into the depth of knowledge that the class was intended to because we lost maybe an extra week and a half of instruction. So I had to condense everything down, perhaps even 2 weeks back then. And so this is gonna go into what we would normally do in a Math 120 course. So 10.1 is a little weird, which is why I feel like the math is easy. Easy is always a tricky word to use because not everybody sees that it's easy. The math is less complicated, but the language makes it seem like it's difficult. That's my summary of section 10.1. And so I typed out all of the kind of strange things that you would see if you read the textbook. And then I'm going to show you through examples that it's not as hard as you think it is. So the square root, a number C is a square root of A if C squared equals A. So just to rephrase that in an example form, find the two square roots of 36. Well, the square root of 36 can be 6, and the square root of 36 could also be negative 6. Because if you multiply a negative times itself, it always turns into a positive number. So just when you think, oh yeah, that makes sense, everything for chapter 10 is going to use what we call the principal square root. And the principal square root is the non-negative option. Why didn't they just say positive? I'm not 100, it has to do with 0, but it translates to take the positive answer, okay? So if this was our example for moving forward, the square root of 36, we're just gonna take the positive answer. And we switch all that when we get to chapter 11. So it's kind of not fair because you kind of get used to just doing the positive. And then when we hit chapter 11, we take both answers once again. So this is a temporary thing. So the square root of 25 is automatically 5. If it's in a fractional form, don't let that intimidate you. The square root of 64 is 8. The square root of 9 is 3. And over here, if you have that negative out in front of your square root, then square root of 100 is just 10, and that negative can just travel straight down. So I would think, but you've already done the factoring chapter, and then applying that factoring chapter in chapter 6, knowing those perfect squares, 1 through 144, 12 to 12 is 144, or even 15. And the more you know without relying on your technology, sometimes it's just easier to have that recall. So I like to tell students to memorize all the way up to 20 to 20, 20 times 20, but you know, 19 times 19 doesn't really come up that often. All right, so the next little part says cube roots. The number c is the cube root of a if c to the third power equals a, or the cube root of a equals c. And sometimes it's just writing the math and you're just like, I don't even understand what that means. So don't get bogged down in the language that you might see if you look at the book or anything like that. Let's just plug it in and then you can just use your calculator. And so the cube root, if I substitute 125 in for y right here, the cube root of 125 is 5, and we've done this again when we factored our perfect cubes because 5 to the third power is 125. All right, if we substitute in a negative 26 right here, negative 26, subtract one more, is the cube root of negative 27. And if we're going to discover, I think it happens even maybe right here, we're going to discover that if this is an odd number, you can have a negative underneath the radical. And so this is actually going to be negative 3 because negative 3 raised to the third power is negative 27. So, and I think I've shared where to find some of those buttons on your calculator. Not sure. So just in case I have not, for this particular chapter, depending on what kind of technology you use, let me just click out of this real fast. Depending on what kind of technology you use, some calculators are going to have a very specific cube root button. Some might require you to put in that number first and then hit that, while other calculators would have you type that in and then type that before you hit your respective equal sign. Other calculators will maybe look like this, okay, and have some of those types of things. You're also looking for buttons. The letters are insignificant. Some of those types of buttons. We're going to utilize all of those when we look at chapter 10. If you're using just your normal phones for your calculator, once again, if you turn your iPhone horizontal, it will bring up more buttons, but it's not as user-friendly as far as how the keystrokes work, what you have to hit first. You have to kind of do things sometimes out of order. All right, this one we did. Let's scroll down. All right, the principal nth root. So if you printed this, I sent it through email, through Canvas. And so if you printed this, even if that giant circle is kind of blocking some of your work, hopefully you have that right there in front of you and it'll make up for that. So the principal nth root. The nth root of b, the radical piece is clearly the radical sign. B is called the radicand, and n is called the index, aka the root. So the cube root, the fourth root, the fifth root. We tend to use the word root more than we use, or I do anyways, more than I do the word index. And I find this to be rather confusing language. And so what I want you to remember is this kind of goes back to an idea that hasn't shown up yet on the board. So this gives you a lot of different examples. Most of these come straight from the book. And I will illustrate these two concepts when we look at these examples here. But this was just an opportunity to practice those nth roots and show you that some of them aren't possible. So, cube root of 64, you can throw that right in your calculator and practice that. Or if you know some of your perfect cubes, 4 to the third power is 64. And so if that is negative right there, then this would be a -4. The square root of 64 has a different meaning altogether. And so the square root of a negative, you can't come up with the square root of a negative because there's no number. Like if you try -8, there's no number when you multiply it by itself that will result in a negative number. Like -8 won't work. Clearly +8 won't work because it's not going to change to a negative. And so if you have a negative underneath your radical, and this is an even root, and it's always a 2 when we talk about a square. We don't write that down, but that's the implication. And so if that is any even number, it doesn't work. So that circle with the line through it is again a symbol for empty set, if we've talked about that before. Now, if you have a negative outside the radical, you're good. -8. Here, the 4th root of 81, well, 3 to the 4th power is 81, and so I could rewrite that, but I allow you to use technology in this course, but this then at least puts it in this form, where those two pieces match. So the 4th root of 3 to the 4th power, and so the idea here is that those just cancel each other out, and you get the number 3. All right, coming back to this one, same thing here. All right, -4 to the 3rd power, and then this is the cube root, and so the idea here is that they cancel each other out. If you have the 9th root of a negative number, you're okay because you are allowed to have negatives anytime this is an odd. And so that goes back to that idea right there. And so this would just be -1. But if this is even, you cannot have a negative number if this is even. So just to illustrate how differently those can look, empty set. And then here is finally an example that illustrates the need for those absolute values. And so watch what happens. If I'm taking the square root of something squared, but this can't be -5 for an answer because we're only taking the positive option. So what's happening here is -5 times -5 is +25. And then we're agreeing by this principal square root idea to only include the positive answer. So we're saying, hey, make it positive, all right? And so hence the need for the absolute values. If you were just gonna absolute value right there, you would get a +5, all right? So the answer to this one rewritten in this form, because that's a 2, so those match, it cancels each other out. And so if I just took that, I would need absolute values around it because we are taking the positive option of that. So just said differently, but I don't want to get bogged down on that one thing because there's a lot of different pieces in these 2 lessons. All right, but if this is odd and that is odd, then this can just break free. And it follows that pattern right there because for odds, you're allowed to have an answer that's negative. All right, domain of radical functions. One of these is markedly quicker than the other. And it again goes back to that idea of whether or not you're allowed to have positives or negatives underneath the radical sign. So if the root is even, okay, 2, 4, 6, 8, 10, any even root, then what is underneath the radical sign must be greater than or equal to 0. Because again, it goes back to the idea that you can't have the square root of -9. There's no way to come up with a number multiplied by itself and get a negative. So, if this is any even root, what you're going to do is you're going to take the expression that's underneath the radical and set it greater than or equal to 0 and solve for x. So move the 7 to the other side. Minus 3x is greater than or equal to -7. Divide by -3, divide by -3, and you get for an answer x is greater than or equal to 7/3, which is an acceptable answer in my math lab. And so when you get to college algebra, normally I teach with something called interval notation. Just note that some of the ways you write your answers on these might change as you move up in your math courses. All right, over here though, and did we flip the sign? I did not flip the sign. I thought about it as I was rewriting it, and then I was thinking about how my pen was running out. When you divide by a negative, or multiply by a negative, and you have inequalities, you need to flip that. I knew I needed to go back and do something. So that sign does flip, and it's going to be x is less than or equal to 7/3. My bad, but at least I caught my error right away there. Okay, over here, this is allowed to be any number. Okay, again, if you have some random example, the cube root of -8, -2 times -2 times -2, this gives you a +4 times a -2. You're allowed to have a negative if this is an odd root. It works out fine. So, anytime that is an odd root, an odd index, what is underneath the radical sign can be any number. It doesn't matter whether it's +0 or negative. So therefore, this one is way less complicated. This is all real numbers. All real numbers will work anytime that is odd. If this is even, then you set it greater than or equal to 0, and my apologies for making that mistake there. All right, that is the end of 10.1. So I'm just gonna I'll pause it right there, and then I'll start a new one, and I'll just kind of check and make sure that it's not so glary you can't see it. So have a great day, and if you're watching 10.2, it starts right there. I'll be right back.